Hello students, today I will discuss about electric dipole. So this is the fourth part of the first chapter, electric charges and fields. Electric charges and fields is part 4. This electric dipole. Electric dipole. Here we discuss about what is electric dipole, what is electric dipole moment, and we find the electric field due to electric dipole, torque due to electric dipole, and work done in rotating a dipole in the uniform electric field. Okay. So now, what is electric dipole? Here it is dipole. So electric dipole means what? It is a combination of two equivalent opposite charges. This is electric dipole. So this is electric dipole. Simply you can say that the arrangement of two equal and opposite charges. What is dipole? The arrangement of two equal and opposite charges. Opposite charges separated by distance. Separated by a distance. So this is called electric dipole. So this is electric dipole. Okay. Magnitude is same, but nature is opposite. One is positive, another is negative. Next is electric dipole moment. Electric dipole moment. Okay. So it is simply a mathematical term. It is defined as, say, the length of the dipole is 2a. Okay, or 12. So this is the length of the dipole. So by convention, negative charge is placed at the left and positive on the right side. Okay. Now what is dipole moment? It is the product of magnitude of charge. Okay, product of magnitude of either of the charge and the length of the dipole. So this is called dipole moment. It is denoted by P. So it is equal to what? Q into 2. So this is dipole moment. Okay. So this is simply mathematical term. It is defined as what? Product of the magnitude of either of the charge and the length of the dipole. So it is a vector quantity. Okay. It is a vector quantity. It is a vector quantity. What is 12 here? 12 is what? Length of the dipole. This is length of the dipole. Okay. So we considering the length as 12 because in our next derivations it is simple to consider 12. Okay. You can take L also. So here 12 is the length of dipole. Don't confuse. L is not length of dipole. 12 is length of dipole. Okay. And what is direction of the dipole moment? It is from negative charge to positive charge. This is by convention. Okay. The direction of dipole moment is from negative charge to positive charge. Okay. And what is its unit? Here Q into 12. Q is charge, coulomb. So it's SI unit. SI unit is what? Coulomb into meter. So this is about electric dipole moment. Product of magnitude of charge and length of dipole. It is a vector quantity. Its direction is from negative to positive charge, and its SI unit is what? Coulomb into meter. So this is electric dipole moment. Okay. Now we will find the electric field due to an electric dipole. Okay. Electric field due to an electric dipole. So first we take at a point on the axial line. So what is axial line? So here suppose this is the dipole, here it is minus q, it is plus q. So this line joining, this is called axis. Okay. Now we just consider a point here. This is the point P. We want to find the electric dipole moment at this point. Okay. So here you see this is the length of dipole. So it is 12, and this is our center. Center of dipole is O. And this point P is at a distance of what? R. Say R from the center of dipole. So what is this distance from plus q charge? This distance will be what? Obviously from it is R and it is L, because it is total is 12. So here it is L, here it is L. So this will be what? R minus L. And from minus q, this distance is what? Up to this is R, then it is L. It is R plus L. Now, as I have told you, to find the resultant electric field, you have to find the direction first. So first you find out electric field at this point due to positive charge and then due to negative charge. Now this is positive charge, so direction of electric field is what? Outward. Already I have discussed in last part. So for positive charge it is say E1. It is say E1. So outward, away from the charge. And for negative charge it is inward, towards the charge. So this is what? E1. Okay? Sorry, it is E2. So for positive charge, electric field is outward, so it is away from the charge, that is E1. And for negative charge, it is inward towards the charge, we take it as E2. Now we can find out total field at point P. Okay? So the magnitude of electric field at P due to plus q charge. So derivation is very simple, just you have to use the formula. So for plus q, this is the field E1, and distance from plus q is what? R minus L. So E1 is equal to what? Use the formula 1 by 4 pi epsilon, it is q by R minus L whole square. Because distance is what here? R minus L. So this is equation 1. Similarly, find out the magnitude of electric field at P due to minus q charge. So it will be what? E2 is equal to 1 by 4 pi epsilon q by R plus L whole square. Because you see here from minus q distance is R plus L. Now you see the direction. E1 towards right, E2 towards left. Okay. So they are in opposite direction. So what is the resultant field? Therefore, the magnitude of net electric field at P, it will be what? E is equal to E1 minus E2. So why it is subtracted? Because you see direction E1 and E2, they are in opposite direction. That's why it is subtracted. Okay, E1 minus E2. Now just you place the value. Okay, E1 here and E2 here, and then just you simplify, you get the result. Okay. Now what we do? We just put the value of what? E1 and E2. Here, now E is equal to what? E1 minus E2, you put the value of E1 here. So 1 by 4 pi epsilon q by R minus L whole square minus, put the value of E2, 1 by 4 pi epsilon q by R plus L whole square. Okay. Now just simplify. Rest is very simple, only general mathematics. Okay. There is no physics. The physics part is just to find the direction. Now you take common. Q by 4 pi epsilon, you take common, is 1 by R minus L whole square minus 1 by R plus L whole square. So Q by 4 pi epsilon, you take LCM, okay, R minus L whole square, R plus L whole square, it is R plus L whole square minus r minus L whole square. So q by 4 pi epsilon, so here it is r minus L, r plus L whole thing square. Here it will be a plus b whole square minus a minus b whole square. It is 4ab. So 4ab. ab means what? It is r into L. So q by 4 pi epsilon. It is now this you can write 2L into 2r. Okay, and here it is s square minus b square. So r square minus L square whole square. Now here you see, we know dipole moment. I have already given you q into 2L. So this is dipole moment. Okay. So in place of this q into 2L, here you can write p, or you can write one step q into 2L into 2R by 4 pi epsilon r square minus L square whole square. Now here we now you can place the value of this is what? Dipole moment. Okay, P. So E is equal to what? P into 2R by 4 pi epsilon. It is r square minus L square. So this is the expression of what? Electric field due to an electric dipole. Okay, P into 2R 4 pi epsilon r square minus L square whole square. Here P is what? Dipole moment. That is Q into 2R. So this is the expression. Now we take one assumption. What is the assumption? If the dipole is very short, then if dipole is very short, then that is L is very less than R, then L can be neglected. Okay, L can be neglected. So in that case, what will be E? You neglect this L. It is P into 2R by 4 pi epsilon r square whole square. Okay, we neglect this L. So it will be P into 2R 4 pi epsilon r to the power 4. So 1 r cancel out. It will be 2p by 4 pi epsilon r cube. So this is the expression of what? Electric field. E is equal to what? 2p by 4 pi epsilon r cube. Now if you write in vector form, in vector, you see direction of E is what? Along this direction, resultant field. So you can simply put E is equal to, P is a vector quantity, it is along the dipole moment, 2p 4 pi epsilon r cube. So this is in vector form. Okay. So this is very simple. First you find the direction of electric field due to positive charge. It is E1 outward. For negative charge, it is inward. So resultant will be what? E1 minus E2. Why E1 minus E2? Because they are in opposite direction. The rest simply calculation. Okay. So now we will find the electric field at a point due to equatorial, at a point on equatorial line. Okay. Next we find out electric field at a point on equatorial line. Now what is equatorial line? You see, so this is the dipole suppose. This is the dipole. Okay. Minus 2 here, it is minus 2, it is plus 2. Equatorial line means what? You draw a normal. At the center of dipole. So this is called equatorial line. Okay. Normal at the center of dipole. This is equatorial line. So this point is P. This point is P. This one. So distance R. So dipole, this length is 12. So consider all of it. Here it is L and also L from the center. So same procedure. First you find electric field at point P due to plus Q charge. So it is positive charge will be outward. Outward means what? You join this line. Okay. So outward means what? Away from the charge. So at this point. So this is E1. Now you find electric field due to minus q charge. This is negative inward. Inward means what? It is towards the charge. So you join this one. It is towards the charge. This is E. Okay. So I repeat. This is positive charge. So this is E1. Along this outward positive. This is negative inward. So this is the resultant electric. You have to find out this resultant field. It is E. So E you have to find out. Okay. E you have to find out. Now suppose first of all you see. Suppose this is A. This is B. This point is P here. You find out electric field at point P due to plus Q. Then you find for minus Q. Then you find the resultant. This angle suppose theta. So this also theta. Because these two distances are equal. Okay. And this also theta you can consider. Apparent angle. This is theta. So last let me find out electric field at this point. Okay. The magnitude of electric field at P due to plus Q. What will be its value? You tell me. E1 is equal to what? You just use the expression 1 by 4 pi epsilon Q by R square. R square means what? Now this distance. Okay. BP square. Okay. So E1 is equal to 1 by 4 pi epsilon Q by. Now what is BP? BP is what? This distance. Okay. So it is this square plus this square. Factorial theorem. It is R square plus H square. So this is BP square. Then you find out the magnitude of electric field at P due to minus Q. What is its value? Tell me. E2 equal to 1 by 4 pi epsilon Q by. Now take this distance. Okay. It is AP square. What is AP square? 1 by 4 pi epsilon Q by R square plus H square. So this is E2. So now you see the expression E1 and E2. They are exactly same. Okay. So from 1 and 2 you can say what you can say? E1 is equal to E2. So the magnitude of E1 is equal to what? E2. E1 is equal to same expression you see 1 by 4 pi epsilon Q by R square plus H square. Same expression. Okay. Now here you see if we take the component, this suppose x-axis and this suppose y-axis. Okay. So E1 has two components. Along this it is E1 cos theta and along this it is E1 what? Sin theta. Similarly for this E2 along this it is what? E2 cos theta, along this it is E2 sin theta. Now you see E1 is equal to E2, but these two components you see. So E1 sin theta upward direction, E2 sin theta downward direction. Since E1 is equal to E2, so they are equal but opposite direction. So these two cancel. They cancel. Why they cancel? Because you see E1 sin theta and E2 sin theta, they are equal. Why equal? Because E1 is equal to E2, so E1 sin theta is equal to what? E2 sin theta. But they are in opposite direction, so these two cancel out. What remains? E1 cos theta and E2 cos theta, and these two are in same direction. So what is total field? What is the total field? Therefore, the magnitude of net electric field. Okay, net electric field. It is E is equal to what? E1 cos theta plus E2 cos theta. So now you just put the value of E1 and E2. I have already given you the expression, just put it here. 1 by 4 pi epsilon Q by R square plus L square. Okay, cos theta plus the same expression 1 by 4 pi epsilon Q by R square plus L square cos theta. So it will be what? 1 by 4 pi epsilon Q by R square plus L square is 2 cos theta. Okay, now we put the value of cos theta. Use this triangle. In triangle AOP, if we take cos theta, it is base by hypotenuse. It is AO by AP. Now what is AO? It is L. And what is AP? AP means this one. It is root over R square plus L square. So now you put it here. 1 by 4 pi epsilon Q by R square plus L square. It is 2 cos theta. What is cos theta here? L by root over R square plus L square. So 1 by 4 pi epsilon Q by R square plus L square. It is 2L. This we can write R square plus L square to the power half. Okay, because root over means 2 power half. So just calculate now. So it will be what? E is equal to 1 by 4 pi epsilon. What is Q into 12? It is dipole moment. I have already discussed this dipole moment. Okay, and here it is R square plus L square to the power 3 by. So this is the final expression. Okay, so this is the expression of electric field due to electric dipole at a point on equatorial line. Okay, what is equatorial line? It is the perpendicular drawn at the center of the dipole. Okay, so this is the expression. So here also you can make the assumption, that is, if dipole is very short, it is L is very, very less than R, then you can neglect L. If you neglect L, you neglect this one, so what remains? It is 1 by 4 pi epsilon P by R square to the power 3 by 2. So E is equal to 1 by 4 pi epsilon P by R cube. So this is the formula. Okay. So now here you can see, if you see the expression for axial line, what will got? 1 by 4 pi epsilon 2p by r cube. And for equatorial line, what will got? 1 by 4 pi epsilon p by r cube. So from here, what you can say? For a short dipole, you can write E axial is equal to twice of E equatorial. Okay, so this you can remember. For a short dipole, E axial is equal to what? Twice of E equatorial. So this is the derivation. So these two derivations are very important in exam. In board exam, these derivations may come. Okay, find the electric field at a point due to at a point on axial line due to dipole, or find the electric field at a point on equatorial line for electric dipole. So you have to derive both the expressions. So here only you have to understand the diagram. Rest is calculation is very simple. So this is positive charge here. This is the point P. The direction is outward. So it is E1. This is negative charge. It is inward along this. So this is the resultant electric field. Then rest you can easily find out. Okay. Next one is next topic, due to electric dipole in uniform electric field. Okay, torque due to electric dipole in uniform electric field. Now here you see uniform electric field is represented by parallel straight lines. Uniform means what? The value of electric field is same at every point. That is called uniform, constant. Okay, so represented by parallel straight lines. So this is electric field. You place a dipole here. This is the dipole. Dipole means what? Combination of positive and negative charge. So here it is minus q and it is what? Plus q. This is the dipole. Its length is what? 2l. Suppose the dipole makes angle theta. So you have to find out the force on these two charges due to electric field. Okay, then you can find out easily torque. So force on plus q charge. So F will be what? It is what? Plus QE. Because you know the expression of electric field I have already given you. E is equal to what? F by Q naught. So this is the expression of electric field. Okay. So what is force here? From here F is equal to what? Q into T. This is the expression of force. So the force on this charge will be what? It is QB. You know the direction? Direction of F is what? Towards electric field. So this electric field. So here this charge experiences the force in the direction of electric field. So it is this direction. So this F equal to plus Q. So in the direction of electric field. Then you find out force on minus Q charge. So it is F is equal to what? Minus Q. So minus Q means what? Here you see this negative charge. So this negative sign indicates what? It indicates that F is opposite to the electric field. Since electric field is along this direction, force on this charge will be what? Opposite to that. So it is minus Q. That means you see this dipole, this charge experiences a force along this direction and this experiences along this direction. They are opposite directions. Okay. So one along this, another along this. So because of this, it will rotate. Okay, it will rotate, and this is called what? Torque. So now this will rotate because this force along this and this force along this, they are in opposite direction. So because of this equal and opposite forces, this dipole experiences torque and it will rotate along these directions. Okay, you have to find out that torque. And what is the expression of torque? You know, so therefore you can say that net force on the dipole. Net force on the dipole. What is the net force on the dipole? It is what? QE minus QB is equal to 0. F net. So net force on the dipole is what? It is 0. So total force 0 means what? It implies what? It implies that the dipole is in translational equilibrium. Translational equilibrium. Okay? Translational equilibrium. Because in laws of motion, you know equilibrium. Equilibrium means what? The total force on the dipole is what? 0. So this is called translational equilibrium. Okay? Because net force on the dipole is 0. But torque is not 0 because with these two forces it will rotate. You have to find the expression of torque here. Force is 0. Total force is 0. But torque is not 0. And what is torque here? So let me find out torque. What is torque here? So therefore torque is given by what? Force into perpendicular distance. Okay. Now what is the magnitude of force? You take the magnitude of force. It is QE. And what is perpendicular distance? You draw a perpendicular here. This is the perpendicular distance. Okay. Now you see this is 12. This angle theta. So this will be what? 12 sin theta. So this is perpendicular distance. Okay. It is 12 sin theta. So into 12 sin theta. So this you can write Q into 12 E sin theta. Okay. Now what is Q into 12? Your dipole moment P. So it is PE sin theta. So this is the expression of torque. So It is PE sin theta. So in vector form you can write it is what? P cross E. You know the cross product? Okay. P cross E. So this is the expression of what? Expression of what? Torque. It is PE sin theta, and in vector form it is what? P cross E. So here what important point to remember, that the total force on the dipole is what? 0 in uniform electric field. Okay. Since total force is 0, it experiences what? No force, means it is in translational equilibrium. But due to two equal and opposite forces, it rotates. Okay. And because of that, it experiences a torque, and that is given by what? P sin theta or P cross E. Okay. So this is torque. Okay. Now let us find out work done in rotating a dipole in uniform electric field. You have to find out work done. Okay, now here you see, due to torque, the dipole tends to rotate along this direction. Okay. Now if you want to rotate opposite to the torque, you will do some work. Okay, dipole is rotating along this, but if you want to rotate opposite to the torque, you have to do some work. That work you have to find out. Okay. So what is the expression of, suppose we want to, the amount of work done to rotate the dipole from initial angle or from angle theta 1 to theta 2. What is the expression of torque? Work done, integration theta 1 theta 2 F d torque d. Now from where you get this formula? Do you know this formula? Work done equal to integration theta 1 theta 2 tau d theta. You know, in work energy power, in class 11, I have given a relation work done due to a variable force. Okay, that is given by F is equal to, if you remember, it is x1 xi to xf f dx. If you remember, okay, this is the formula of work done. Okay, in work done due to a variable force. Now here it is in rotational motion, so just you replace initial position to initial angle theta 1, final position to final angle theta 2, and force into torque and distance into angular distance. So this is the formula of work done in rotational motion, and this is the formula of work done in translational motion. In rotational motion, force can be replaced by torque. Okay, and angular and the linear displacement replaced by angular displacement. So this is the formula. Rest is simple, just you have to integrate here. Torque, replace the value. Already I have given PE sin theta, B theta. So P you can take it outside, PE theta 1 to theta 2 sin theta B theta. So PE integration of sin theta is what? Minus cos theta, theta 1 to theta 2. So you see PE, you put the limit, it will be cos theta 1 minus cos theta. Okay, so this is the expression of what? So you know, this derivation is not important in exam. It will not be asked to derive the work done. Okay, but torque expression, derivation of torque is important. But this formula you have to remember only for numerical purpose. Okay, questions may come to find the work done to rotate, suppose from angle 90 degree to 180 degree or any other cases. You have to find out the work done. So just for numerical point of view, just remember this formula. Okay, this derivation is not required for your board exam. Okay, so this is all about. So I will provide the PDF notes. You do not have to write all these things. Just try to understand, and also I will provide some solved numericals. You go through this, and then you try the unsolved questions. Okay, if there is any doubt, you can ask me. This is very simple. First, you repeatedly you just go through and try to clear the concept. Then remember the formula, and when you solve questions, it will be more clear to you. Okay, thank you.